Hi, and welcome to this Week 2 lesson of PROG1198. This topic is recovery models. So we're going to be learning about how to back up a database and then how to restore from that backup. So if we look at the Microsoft documentation for TSQL, when we talk about recovery models, what it is a property on your database that controls how the transactions are logged, whether the transaction log requires backing up, and what kinds of restore operations are available. So when we pick a recovery model for the database, we need to consider things like how often the database is changed, how extensive the changes are going to be, how often the data in the tables is updated versus the actual structure of the database objects, how often it's accessed and how many people are accessing it at the same time. Also, we want to assess, how critical the data is or how much we can afford to lose any pieces of the data or the transactions. A transaction is an action taken against the database. Now, typically the way that recovery models and database backups and transaction, the way that these things kind of happen is that whenever you take some kind of action against the database, you run a create statement or you insert a new record into a table, all of those things, those transactions, are stored in what's called the transaction log. And the transaction log is an up-to-the-minute record of all of the things that have been acted upon against the database. So when we're backing up our database, it's not just about the structure and about the data, but also about the actions that have been taken. So we have three possible recovery models for SQL Server databases. You can choose simple, which is the default. You can choose full, or you can choose bulk logged. And we'll take a moment to discover what those all mean. The recovery model chosen determines what type of backup and restore options are available. And if you choose simple, or if you leave it as simple, if that's the default, you can easily back up and restore your database without needing to manage the transaction log. So a simple recovery just allows for a backup to be taken, but you're not managing the transaction log, so it's a lot easier and it's a lot less labor intensive. It's also a lot less data. However, you could be facing data loss because anything that's happened since your last backup is not recorded. Now, a full recovery model. This is a higher overhead cost, so it's more complex, but it minimizes data and work loss. So in a full recovery model, you're actually managing the transaction log as well to not only back up the database, but to back up the transactions, that is backing up the record of all of the actions that were taken against that database. The bulk logged recovery model, we're not using that one too often. It's used with bulk operations. That means when you're performing a large amount of operations against the database all at once, and it allows you to minimize the size of the log file. Now, in order to discover the database's recovery model, I've got a little snippet of code in here that allows you to display the name and a description of that database's recovery model from the system's databases list. Let's take a look at that in SQL Server. Now, if we execute this query without the where line, it'll show us a list of all the databases and their recovery models. So we can see that here I've got a list including the names of all the databases on my server and the list of recovery models. And you can see that most of them follow a simple recovery model because that's the default if you don't specify. Now, in order to single out the one that I'm interested in, we're going to be working with the username company database. I can add that into the where line. So rather than seeing everything, I'm just interested in the company one. And you can see how I've got the recovery model as full. Now, if we want to change to a different recovery model, we can do so by writing an alter command on the database. However, if we're going to alter a database, we have to make sure that we're not currently connected to that database. If we look up here, you can see I'm currently connected to username_company database. I have to move away from that before I can make any alterations to it. So I'm going to start with a use command and switch over to using the master database. You can see this code on the slide as well. The next thing we encounter is a go statement. We're going to talk more about the go statement later on in the course when we talk about writing efficient scripts. But for now, all you need to know about go is that it makes sure to commit and successfully execute this change before continuing. So we're going to type go here, and then I'm going to use this alter database command to specify the name of the database that we want to alter. And what alteration we want to make. So in this case, I'm going to alter the username company. It's currently in a full recovery model, so I'm going to alter it and change it to simple. So let's execute this part of the script. We see a success message here, and now if we look up username company, we can see that its recovery model has been changed to simple. So the three options, simple, full, or bulk logged. If you're using bulk logged, notice that there's an underscore in there. Now, keep in mind that the type of recovery model allows you to have access to different types of database backups. So we're going to look at different ways of backing up the database. And some of these work with certain recovery models. Some of them don't work with other types of recovery models. And we're going to learn about how these backups interact with the recovery models. So we've got 4 types here listed of database backups. The first is full. A full backup, as the name suggests, is backing up the entire database. So all of the tables with the data, all of the other database objects like procedures and functions. That's everything. Now, the next one is a differential backup. A differential backup only tracks changes made since the last full backup. So after you create your database, if you create a full backup and then you make a bunch of changes, if you want to back up the changes that you made, you can do a differential backup that just records the changes since the last full backup, rather than creating another brand new full backup. So the differential backup allows you to create smaller backup files, and it also allows you to create different restore points. So if you create a full backup, say at the beginning of the month, and then differential backups every single day of the month, and you say, okay, well, I need to rewind to January 9th, then you can install the full backup and then all the differentials from January 1st to 9th and leave the rest. So that is a good strategy if you're performing restores from backups. We can also back up the transaction log, and this allows for point-in-time restores because the transaction log not only logs the actions but when they happened. So the transaction log, as I mentioned before, is a record of every individual action that has been taken against the database. It's not just the current state of the database, but it's also a list of how you got there. So we can oftentimes choose to back up the transaction log and restore that as part of the database restore. And the last one is file or file group. These are only useful when your database is stored in multiple files. We're not doing that in this course, so we're not going to cover file or file group backups, but it is one thing to consider. Now, in order to perform a backup on your database, you can do this through the user interface in SQL Server Management Studio. If you right-click on a database, you'll see that one of the tasks is backup. There's also a restore option, but we're not going to cover the user interface portion of this because we want to write it in TSQL. We want to create a script file that can perform these actions for us so that we can just open the script file and execute it, rather than needing to interact through the interface. This is going to become an automated process. So we use a command called backup database to create the backup to a file on disk. It's a pretty straightforward command. We start with backup database and the name of the database. And then the next line, we have to disk equals, and then a path to the file that you want to create. Now, I've used an absolute path here, which means I'm starting at the root or C drive, as you can see there. And that provides a concrete pathway to the file. We give the file a name, and the extension is .bak. You can also use a relative path. If you use a relative path, it goes into your database server's default backup directory. On my computer, it's listed here in C, program files, SQL Server, etc. It creates a backup directory for you if you don't explicitly specify a path to the file. Now, your default backup directory might be different depending on which version of SQL Express you've installed and where you've chosen to install it on your own computer. So let's try out this backup database command. So I'm going to add into my script here a backup database command, the same as what we just looked at on the slide here. We'll just move over so we make sure it gets on the screen. So we're going to back up the database to this location on disk. Now, another option is that you can provide a name for your backup. If the rest of your script relies on naming this option, so we can add a name property as well. If we say with name equal and give it a name. But the name isn't required. Either way, we can execute this to create our backup file. So what you should see is successfully processed in a backup database command. And if we take a look in that folder, I've got it as C backups. You can see that it has now created this username_company backup file. Now on the next slide, we'll talk about differential backups. So I've created a full backup, and now that it has been created, we can create differential backups. And I mentioned before that differential backups are just including the changes since the last full backup. When we're restoring from these backups, you would need to use the full backup first, plus the most recent differential backup. When you create a differential backup, it is an extremely similar command, the same backup database to disk, and you can give the file a name. It's a .dif extension for a differential backup, and we need to include this flag that says with differential. So let's try to create a differential backup on our username_company database. So I'm going to start off with a very similar command, but we need to make sure we use a DIF extension. And we also need to make sure that we include with differential. Now watch what happens when I execute this command. I've created the differential backup successfully. And if I look in my folder, now I have two files, the full backup and the differential backup. Now the third type of backup is creating a backup of the transaction log. So if we create a backup of the transaction log, this allows us the minimal amount of data loss if there's a system failure. In order to back up the transaction log, we have to be using either the full or bulk logged recovery model. So if our database is using a simple recovery model, the transaction log is not available to us. You can see that my database here, username underscore company, you'll remember that we set the recovery to simple, which means that we don't have that option to back up the transaction log. The backup statement here is a little bit different. Instead of backup database, we say backup log. The rest of it is similar. So we say toDisk equals, and we put in the path to the file. But if you'll notice here, the extension is TRN for the transaction log. And when we execute this, we'll see that it fails. And it fails with the following error message. The statement backup log is not allowed while the recovery model is simple. So it just gives you that reminder that if you're using a simple recovery model, you don't have the option to back up the transaction log. So there's no way of recording step by step all the actions that have been taken against the database since the last backup. If we do want to use backup log, then we need to change our database again to set recovery to full. So if I perform that action, we can change the recovery model. I'll use this select statement to verify that it worked, that our recovery model is now full, and I'll start that same process again. Now the reason why I want to start the entire process again and not jump straight to backing up the transaction log is because our backups for the full backup here and the differential backup here, those will restore a database that was in simple mode. And if the database is in simple mode, we're not going to be able to restore from a transaction log. So we need to repeat the actions of performing first the full backup, and then the differential backup, and now the transaction log. And we have that successful backups created of all three of those options, and you can see in my backups folder, I have the original full backup, the differential, and the transaction log. So now that we have all of these backups and logs that are stored, how do we restore the database from the backup? Well, assuming, of course, that we have a backup file. You can't restore with at least a full backup. That's the minimum. So if you have the .bak file, then that's a great starting point. Then you check to see, do you have a differential backup or do you have multiple differential backups? And finally, the last thing that you would restore is the transaction log. Because remember, the transaction log just keeps track of things that have happened since the last backup. Now, if you only have the simple backup, then here's the way that we would restore from that one simple full backup file. We have to make sure that we are not currently connected to the database that we are trying to restore. So we start off by switching to the master database. And then we perform the restore command. Restore database, make sure that the name is the same. And instead of to disk, we say from disk, and we provide that same path to make sure that you don't have any typos or anything like that. And then we have with recovery. Now when you're performing a restore, we would say either with recovery or with no recovery. And those two flags indicate whether after the restore, the database is available for use. Sometimes we're performing a restore that takes multiple steps. If we're restoring the backup file, then the differential, and then the transaction log, we have to make sure that the database doesn't get used in between those three steps. So we want to make sure that they all happen before opening the database back up to connections, so that somebody's not using it at that intermediate halfway restored state. So when you have that kind of situation, you would say with no recovery. But here, because we're just restoring from one file and because the restore is going to be done when we're done looking at this backup file, we would say with recovery to make sure that the recover steps are complete, and now the database is available for connections. Now, in the example that I was working on, we had 3 files because I did a more complicated restore, a backup scenario where we have a full backup, and then we have a differential backup, and then we have a transaction log. Now, on the next slide, we can take a look at this more complex restore statement, where we would restore from the full backup, the differential backup, and a transaction log. So if we want to go through all of those steps, you can see how that the commands are similar. We would restore the database from the full backup first, and then we use that no recovery flag. So the no recovery says we're still offline, the database is not accessible, and the reason is because we want to continue installing from other backups. So once we've recovered from our original full backup, then we can move on to the next statement, which restores the differential backup. We're still staying in a no recovery state because we're not done yet. Then we would, last but not least, restore log so that we can restore from that transaction log file. And we remain in no recovery here just so that we can always modify our script later and add in more or remove different levels of the file. So if you have multiple differentials or if you have other files that need to be, and then this is just a common way of organizing a restore script with at the very end, we perform the restore statement with recovery. Notice there's not a file attached to this one. This is just the step that finalizes and closes the recovery statements so that it can go into accessible mode once again, where users can connect to the database and use it. So what I'm going to do is I'm going to demonstrate restoring from the backups. But in order to prove that it's actually working, I'm first going to go into our company database and make some changes. So I'm going to go and use username company. Username company has 2 tables in it. We have department and employee. So we'll start off by looking at some of these pieces of data inside the department and employee. We've got department on the top, employee on the bottom. So I'm going to make some changes to the database. The first one is I'm going to try to drop the employee table. So we're getting rid of the employees and also the relationship between department and employee. So you'll see now the employee table is gone. We still have the department table, however. So I'm going to make some changes to the department table as well. I'm going to update department and set department name to none. Now notice I didn't put in a where line, so I updated all the records in department to have no names. So my database tables right now have got some pretty serious flaws or mistakes happening here. This is just to illustrate how you can use backups to come back from errors against your tables. You know, I accidentally deleted a table, or, you know, I accidentally wrote my update statement without putting a where line, and now all the records got updated. So mistakes like that can be fixed by restoring from backups. If you're making backups often, especially if you're backing up the transaction log as well, then you have that way to get the data back. Okay, so our current state of employee and department is a pretty sorry state. So what we're going to do is we're going to run this set of restore statements to get it back into that usable state. So I'll just paste this bit of code in here. Maybe I'll be able to just give us a little bit more room so we can take a look at it before we execute it. That it's the same code from the slide where we make sure that we disconnect from username company first, and then I'm going to perform a restore first from the full backup then from the differential backup, and finally from the transaction log. And then I'm going to use this final restore statement to say that no further actions for restores can take place right now against this. It's saying we're done, it's recovered, go ahead and start using it. So we'll execute all of these, just highlight them all and execute. Now you can see that we have a little bit of an error happening here. And part of the reason for that is because you can see that the tail of the log has not been backed up. So it's asking us to back up the log with no recovery if it contains work that we don't want to use, or we can use with replace to restore. So the meat of that is saying, hey, there's been some changes to this database since you last backed it up. Are you sure you don't want to back it up now? Before you try to restore it, you're going to lose everything that you've done since the last backup. It's warning you. Things have changed, and you have not saved those changes. So the restore doesn't work if you try to perform it when you have unbacked up changes. That's the default action. The way to get around this is to choose a replace option. So if we look at the next slide, we have to say that we want to overwrite the existing database. So when we're performing a restore, there's a lot of things that we have to take into account. We want to ensure that your database is in the correct recovery mode. You know, you can't restore a simple database if it was backed up in full mode or vice versa. Also, if your database is in full mode and you have made changes since the last backup was made, the restore will fail. That's what that demonstration was all about. We want to force overwrite of the unsaved changes. So in order to do that, we use the replace option. See after with recovery, comma, replace. And putting in replace says, yes, I know I've got unsaved changes, but that's kind of the point. That's the reason why we want to overwrite. So we're going to choose to replace. Now, another way to get around that is to just create another backup with a different file name and then restore from your original one instead. But using the replace option is obviously a very convenient way to replace the existing database without having to back it up. So let's add the replace flag onto our restores. And we'll give it another try. So you can see by adding the replace to my full backup, the full backup file replaces the existing previous state of the database. And now that we have the database recreated by this first one, the differential backup will build on top of the new one, which of course hasn't had any actions taken away from it yet. And then we restore the transaction log last. We complete the restore by saying that the recovery is completed. And you can see down here that we got the successful restore. However, you'll notice we still had a problem with the transaction log. And this illustrates how the transaction log is working. There's a gap in the log chain. What that means is it recognizes that we chose to replace the database after some unsaved changes happened. So restoring the database itself worked, but restoring the transaction log didn't work because we didn't back up all the transactions. Now, because of these issues with the gap in the log chain, that is, we didn't restore the database properly, part of the transaction log is missing. What I'm going to do in order to demonstrate it properly is I'm going to start with a completely fresh new version of the company database. I'm going to create the backups properly, and then I want to show you how to do what's called a point-in-time restore, where if we know the time, like the literal date and time of when we want to restore our database to a particular point. I'll show you how to perform the restores in such a way that we can restore part of the transaction log without restoring everything. We don't want to restore the mistakes that we made that we're trying to recover from. But we can restore up until a particular point and then just stop restoring from the transaction log at that time. So this is something that can be really useful. If you know when a point of failure happened, you can restore to the closest possible point in your logs or your differentials up until before that mistake or error or failure happened. So in order to remake the company database, I've opened up here the script file that generates this database. So this is our company.sql that makes the department and the employee tables. It's going to drop my old version of username company and create a new one. So I'm just going to execute this script so that we get a brand new fresh version of username company. Just to demonstrate that it is working as expected, we can select all from department and select all from employee. So we can see there's our fresh new version of this database. The other thing that I want to point out is because I didn't specify a recovery model, it's set to simple. And simple recovery models don't allow us to restore from the transaction log. If we want to do a point-in-time restore, we need that full recovery model. So my next step here before I do anything else to this database is I'm going to change it over to a full recovery model. So I'm just going to get out of this script file. I'm not going to save my changes or anything like that. Maybe we'll just get a brand new one and start from there. So I want to alter our database. In order to alter username company, I have to make sure that I'm not connected to it. I have two query windows open here, so we want to make sure that neither one of them is connected to it. Another option is you can use a command to set it offline. We can cover that in a different class. It's not part of today's lesson, so I just visually made sure that nobody's connected to it here. I want to write an alter command. We alter database to set recovery to full, and we will execute that. And we can use that query that I showed you earlier to verify that it worked. So we'll just paste that into here, and we'll execute this to make sure that username company uses the full recovery model. So here's my plan of attack. The first thing that I want to do is verify to make sure that the tables are there and that they exist and that they are in good standing. So I'm going to select all from department and select all from employee. Now I'm still using master, so I'm going to switch over to the username company database, and we'll prove that our database has been correctly implemented here. We've got the two tables, the data is all good. Okay. Now, my goal here is I want to create some backups of this database. Once I've got some backups created, I'm going to make some changes, but it's undesirable changes, things that I don't want to persist. These are the things that, I'm pretending to make some mistakes here so that we can restore to a previous version of the database before the mistakes were made. So I'm going to perform some backups first. Then I'm going to write some oops code to make some mistakes. And then I'm going to restore from the backups and stop the restoration procedure before we get to the mistakes, so that the restore gives us an older but more correct version of the database. So I'm going to start by creating a full backup, and then we can create a differential backup too. Now, because I'm doing them back to back, the differential backup isn't going to contain any changes because nothing will have changed since the last one. But I want to make sure that you have a full example. Now, typically what would happen is, depending on the use of your database and the frequency of changes and the importance and sensitivity of the data, You might have a situation where you perform full backups once a month and differential backups once a week. Or you might have perform full backups once a day and differential backups every hour. Or maybe even something more frequent or less frequent, depending on what your data represents. But for the purposes of this demonstration, I'm going to create the full backup and then create the differential backup right away. So we already looked at the code to these. So I'm just going to copy and paste those into here as the next step in this process. So I'm going to create these two backups. And then after that, I'm also going to back up the transaction log to minimize loss. Let me just move this down so that we've got more space to look at the code. So our full backup is here, differential backup, and then the transaction log. So let's create those three files. So all of those were successful. You can see the backup here, and then the differential, and then the log. Now to verify that that worked correctly, I'll take a look at my folder, and there are the three files in the C backups directory. So they're all there. Now I want to take note of the time. The time on these for modified date, they're all at 4:52 p.m. Now I'm going to consider that as the last time the database was in a desirable state for us. To verify this, I'm just going to show the current system date time. If I execute this here, you can see that right now it's 4:53 p.m. or 16:53 if you're using a 24-hour clock. Any changes that I make are going to happen after that period of time. Now, if I want to restore the database to a time period before any changes that I make, I'm going to have to restore it, to 4:52 p.m. or to 4:53 p.m. So the idea is we're going to provide a date and time to stop the restore process. Okay, so let's mess up the database. In order to mess up the database, so to speak, what I'm going to do is I'm going to go in and I'm going to remove the employee table and I'm going to make some changes to the department data. Now, before I do that, I'm going to display the current data so that we can see before and after. Just some select queries. So here's what it looks like before I make some changes. And now here's some changes. Drop table employee and update department set, department name equal none. So we'll execute those. And now when I try to take a look at department and employee, well, it gives me an error on employee because that table's gone. And you can see how all the department names have been erased. So now this is the point where we say, uh-oh, we need to restore the database. I have messed this thing up. Let's set it back to the point at when we last backed it up. But you saw in the previous example that it isn't quite that simple because it doesn't allow me to perform the restore without restoring all the transaction logs. If I try to restore it using this transaction log from 4:52 p.m., then I have, that gap where it's saying, well, we're missing some data here. And it's really a protection thing, right? Like it doesn't want you to accidentally miss a whole chunk of the database. That's kind of what it's trying to prevent. If we knowingly want to do this, though, here's what we need to do next. The first thing that we need to do next is back up the transaction log again. And you think that that sounds counterintuitive because these are precisely the transactions we want to get rid of. However, the recovery model will not allow for those gaps in the transaction log. It's saying, this time, these actions have to be accounted for. So our next step here before we can perform the restore is to back up what's called the tail, that is the last unsaved portion of the transaction log. So I'm going to perform another backup of the transaction log. Now it's the same as this code, so I'll just copy and paste that down here. However, I don't want to overwrite my old version of the transaction log, because then I would lose the transactions that I want to keep. Now you can overwrite it, but I think it's a little bit safer personally to just give this file a different name. And then when we're performing the restores, we can say restore from that one and then try to restore from this one, but we're going to tell it to ignore this one. So I'm going to call this one username company tail. So we'll execute this to back up the end of the transaction log so that we don't have any gaps in the backups. We know the recovery model does not like that. Now you'll see I have 4 files: the full backup, the differential, the original transaction, and now the tail. So now I can perform the restore sequence. Now we saw it in the earlier part of this video, so I'm going to just paste in that same code that we had from the other file, where we need to disconnect from the database before restoring it. We restore from the full backup first, then the differential, and then the transaction log. But now that we have 2 transaction logs, I'm going to restore from this one first, and then I'm going to put in the next one as well. So I'm going to copy this code for the transaction log and make sure that I get the tail as well. Now, what about we don't want to restore these transactions because they were undesirable to us? Well, this is where the next piece comes in. We want to tell it when to stop. And that's why when I ran that get date back here, telling us that it was, at the time when I ran it, it had just become 4:53, we're going to tell it stop restoring this log file, and we're going to give it that stop time. So an additional option after no recovery is I'm going to tell it stop at equals, and we put in the date and time where we want to stop restoring from these transaction logs. The transaction log contains a record of all of the actions, but not just a record of the actions, but a serial number, so it keeps them in order, and also the date and time of each action. So the actions that I want to get rid of happened after 4:52 p.m., January 13th, 2022. So I'm going to tell it to stop then, January 13th, 2022 at 4:52 p.m. So that's where we're going to stop. Anything after that will not be part of the recovery process. Now the last piece we need in order to fully complete the restore is this piece here that uses the with recovery option, saying that the recovery is now completed and we put the database back online. So we execute all of these in the entire process. Now we'll check to make sure they were all successful. As we scroll down, you can see I didn't get any error messages, but now is the moment of truth. I'm going to go into my username company database again and make sure that it was restored to a good state before we deleted and dropped that information. So I'm going to use username company and select all from department, select all from employee. Oops. So let's give it a try. So as you can see, my department names are intact. My employee data is intact. The table has been recovered from the restore process. So depending on which recovery model you're using, if you're using a simple recovery model, The data loss may happen because you can't back up the transaction logs and restore to a particular time from those logs. But it really does simplify the backup process because you don't have that extra log management or those files to deal with. Alternatively, if you use a full recovery model, you can see how powerful it can be, that you can restore to almost any point in time. As long as you, maintain the log files well, then you can recover most changes. So that's just a little bit about recovery models. Now, in our slides here, at the end, I've put in some links to some Microsoft documentation pages. Their documentation has so many different examples and scenarios and types of recoveries that you can do. So if you're interested in this topic and you want to learn more about it, I suggest starting here at one of these 4 links. There's a lot of good information there about using backup and restore in different ways and different situations. So I hope you guys enjoyed this topic and that you learned something. And if you have any questions about this or any other of the course topics, please send me an email or drop in on our class Collaborate session. I hope you all have a great day. Bye for now.